because it's so packed with stuff, right? Lots of concepts we need to know for this unit. So here we go. So a car is parked in point A. Let's go scout. Starts walking in this direction until this point B is reached. So let's see here, south 35 west. So I'm going to make my compass rose, right? And I'm going south and then 35 degrees towards the west. So that's where I measure from the south line going that way. And so this is point A, and I'm going to point B here. Okay. Marks on the GPS, then continues the expedition north 19 west. So it's going to be a little tight here. Let's see if I can make this work. This is north, and I'm going 19 towards the west, so something like this. So the 19 is right here. How does it give me a distance? 3.8 kilometers. So this is 3.8. Just make sure whatever you do, you're not going to line up perfectly with where you started. Always a little offset. Okay, so 3.8 kilometers. The distance between the second point, so this is C, to his car is 4.7 kilometers. So we've got 4.7 going here. Okay, and this is not lining up with this west line, right? This stretch here, but we know that that is 4.7. Okay, so I would say if you made a mistake here, you take off one mark already. And I always suggest to make a clean version of this. So we're gonna try to copy this, and this is A, B, C, and this is 3.8. This is 4.7. And now we need to figure out this 35 here, right, is touching the south line, and this is basically north-south line. This is also the north-south line, so these are parallel. So I can use the alternate interior to bring in the 35 there. Okay, and that adds up to 54. So I would want to see 54 here. Okay, so if you have just the basics in there, 1, and this 54 itself gets another 1 right there. So it's 2 marks already. What is this asking? Calculate the total distance traveled. So we need to figure out all three sides basically. So the ultimate goal is finding this, and then we add. Okay. So at this point, you realize that you have a pair here. So you would start with sine of 54 over 4.7. So this is what I would say here. If you made a mistake at all, like you didn't get the 54, you lose 1. But if you still have that pair and you start with your pair, like this part, you're still going to get a mark for. So don't go X on this one here. What is the only thing I can do at this moment? At the moment, I can only use this side to help me find the angle across from it. Okay, that's the only thing I can do at this time. So sine of A over 3.8. Right? So you get a mark for the setup, and then you find sine of A, right? You find that, you go cross multiply and divide. This is where I'm going to switch over to, and I have a video of this anyways that I would post. If I don't post this one, I have an older one ready to go. But here it is, okay? And use inverse sine at the end, right? So just remember, you cross multiply and divide just like before. You get a decimal, use all decimals. You use the inverse, you get that. So at this point, right, I give you 1 mark for setup, 1 mark for the mark here, for 40.85. And obviously, if you made a mistake, if you don't have 54, then obviously this is going to be different. We still give you the step mark, okay, step. And then another mark for figuring out the third angle. It's going to be more than 5, by the way, just to make it easier. I don't do halves then, right? And now the step is to figure out this side right here, side C. Okay, so I go back to the original pair, and now I'm using angle C, which I just found, to find side C. I will just give you 1 mark for this step right here in total, just 1 mark for that. All right, and then you get another mark for actually figuring out the total distance. This everybody should get, right? Like, even if you made a mistake on your sides or along the way, if I see you adding up 3 sides, you get the mark for total distance traveled. So let's see here how many marks we're talking about. So 1, 2, 3, 4, 5, 6 for that one, and then 7 for the graph. Right? So you can go ahead and change the 5 out of 7 just to make it a little easier to mark, then we don't have to worry with halves, right? So if you want to see it one more time, there it is. Okay. Next, let's see, this is a quadratic, classic quadratic. Chip is camping. He decides to go cliff diving from the highest spot, which is 20 feet above water. Since he jumps up just before leaving the top of the cliff, he reaches a maximum height of that after this. So this could be height and distance, horizontal distance, but in this case it's time and height. Okay, determine the equation that models Chip's height over time. Just so you know, I want you to know that it could be saying height as a function of time. Don't let that scare you off. Whatever follows the function, right, that is your x variable right here. Time in this case is your x variable. So let's do that. So I would strongly suggest you make a little sketch. We're starting at 20 feet and jumping up to get to the max. And then obviously we're assuming that we're hitting the water at some point. We're splashing, right? This is 0, 20. We are given the vertex, but not always. What's the key for whether or not this is the vertex? What's the word you're looking for? Maximum or minimum, okay? Maximum height, minimum height, highest point, lowest point, something that indicates that that's a turning point, right? Like after that, it goes down again. So don't be thinking the vertex is always there, but you need 3 points. Somehow you need to find 3 points. So this would be 0.82, 24, okay? And the biggest mistake is students go to this point right here and want to mark that one. Don't worry about it. Remember, axis of symmetry, where is it? It's right where the vertex is. And then you focus on this straight path that's followed, that is created up here. Okay, you've got the symmetry happening right here. If you're down here, it's no longer symmetric, right? You're basically just focusing on that symmetry right there. So this would be twice, right? You just multiply that by 2. And that gives you 1.64, and we're back to 20 at that point. And even though it mentioned another point later on, you know this is true. If the vertex is there, you know you can find this third one, and this is all you need to come up with your equation. And then maybe worry about any other point later on, okay? So I'm going to show you my key at this point. By the way, this is worth a mark. That is worth a mark, and the equation is usually worth another mark. How does that work? If you make any mistake here whatsoever, you lose a full mark, okay? But then we honor your points to find your equation. So that's where the step comes in. So 1 mark for this part, specifically that point, and then another mark for your equation, which looks like that. That's the resulting equation. This is supposed to be a 7. There we go. Okay. And then we can ask more questions. It's asking how high is Chip after 1.8 seconds, right? That's the x variable, the x value that you're given. So you second trace value, x is 1.8, and so that is your height. I just want to make sure you understand when you do one of these, zoom 9 is good. It zooms into the points, but you always want to adjust your window after that. What's the domain and range? 0 to 2.83. Why is this here? Because that's when you're hitting the water, right? So the assumption is when we hit the water, we stop. Okay. And then your range, 0 would be the surface of the water, and 24 is like the highest point you ever reach. So this is your, so there was the extra step required to come up with your domain. So what I will do here is, B is just worth 1 mark, by the way. B is 1. For domain and range, I will give you 1 mark for actually going through the steps of finding the x-intercept. Then I'll give you 1 for domain and 1 for range. And if you, for example, if you didn't do this work and you just came up with that somehow, you still get 2 marks for that because you, I'm assuming you figured out the x-intercept. Okay. If, listen carefully, if you made a mistake and called this 1.640 right here, then your domain obviously is 1.64, right? So in that case, you would lose the mark, right? Like you technically didn't do this step, so you lose the mark for actually finding the x-intercept. It's almost like you did less work than what was required. So let's do this again. 1, 2, 3, 4, 5, 6. So 6 in all for question 2. So we've got 7 and 6, 13 for this page. Okay, so you want to put at the bottom here, it's out of 13, and then start adding it up. So some trig, some quadratic. And let's do the, I hope this helps you kind of brought back some of the concepts we've covered before. So we're told that this is a parallelogram. Okay, what's so special about it? So if you follow the letters J, H, I, K, like all this around. So this is parallel to that, and then this is parallel to that, right? So you've got, you can jump this way and this way without any problems. So it doesn't say that you can only use it once. So let's go with X first. I'm going to start there. I'm going to use this, the alternate interior, so 86 degrees. Alternate interior angles are congruent. That's my explanation. For Y, I'll do Y next. That's my second one. What are these? This one and all of this is their consecutive interior, correct? And they add up to 180. So the way I'm going to show my work here is I'm going to go 180 minus 58 minus this one, which is 86, right? And you get 36 degrees there. So always half, you get half for the number, half for your explanation in this case. A, I'm going to use alternate interior here as well, or you could use sum of triangle even if you'd like. But regardless, it is the same as Y, right? So it's 36. Alternate interior angles are congruent, or sum of triangle is equal to 180, right? So regardless of how you did it, that's fine. Z, there's a couple ways you could do this. If you see this is also alternate interior here, you could do a straight angle right here. Maybe I'll use that one. Straight angle is equal to 180. So just go 180 minus 86 minus whatever A is, which is 36, right? And you get 58 degrees. So I actually did it in this order, in that order. Next, a little bit of polygons here. 1 mark for each line basically up there. Calculate the values of x, y, and z. I'll do this one first. And you count, right? This is 12. 12-sided. It's a dodecagon. And so to find x, I'm just going to show you the key for this one. You just use the interior angle formula and just make sure this is n, right? This should be 12. So it's 10 times 180 essentially divided by 12. So it's 150 is the value of x. And next I found, is this z? Yeah, I found z here. And so basically this is an exterior angle. So I go 360 divided by n, which is 30. Or remember this, right? Z is going to be 180 minus whatever x was, because they're supplementary. So regardless of how you did it, you get 30. And then for y, that's an inscribed polygon. That's a diagonal right there, and it's a pentagon. Pentagon has a sum of 540. We take away 3 interior angles and always divide it by 2. Okay, just make sure you do the top first before you divide, and then you get 45 degrees there. This is what I will do today: is 1 mark for interior, 1 for exterior, and 2 for y, which is the inscribed pentagon there, inscribed polygon. And last but not least is your classic cosine law, right? Side, angle, side. So if the angle is sandwiched between the two sides, you can think of it this way: there is no pair, it must be cosine law. The only thing you can do here is solve for this side first. So that is the first order of business. You use this formula. I'll make that worth 2 marks. Okay, 2 marks for this one. And I don't know how you proceeded from that point, because you could do sine law, cosine law. I don't really care. Just make sure that E is worth this. We'll make that worth 2 marks as well. And then the last angle you need to find, we'll make that worth 1 mark. So we are 5 at the bottom. So I'll just use my other, I'll use this one. So we have 5 here, right? 5 marks associated with the last one. 2 for this side, so 2 for this side. 2 for one of the angles. You may have chosen to go about it in a different order. That's fine. Okay, so 2, in my case, it would be 2 for angle E, and then 1 for that other angle that remains. Okay, so 5 and 4, that's 9, and another 4, that's 13. 13 for the back side. And what was the front? Also 13. How did it end up being 21? Don't know what happened. It is 26, yeah. I know that 21 is off anyways, but I didn't know it was 26. But there you go, 26. Name and last name on there.